Quadratic features and graphing from tables. Okay, so we've done a lot of solving quadratic equations. Next, we're going to get into what these actually look like on a graph, okay? So here it says here, quadratic functions, one of these x squared functions, produce U-shaped graphs. So if you look at my hands, they're going to look like a U. They're going to look like a U. They're a U-shaped graph, whether they open up like this or they might open down like this. They're going to do like an a right side up U, or maybe an upside down U where it opens down. But U-shaped graph, these U-shaped graphs are called parabolas. Okay, so that's how you say this word. They're called parabolas, and they have the following features. So they'll have a vertex. So the vertex is the coordinate of the maximum point or the minimum point. So if it looks like, let me just kind of draw a couple coordinate axes. So if it opens up like this, like a regular U, the vertex would be that point there. Like, let me zoom in. Would be like the minimum point. Or if it opens down, if it's an upside down U, it could be the maximum point and be that point. So the vertex is that point where it either changes from decreasing to increasing, that minimum point, or when it changes from increasing, hits the maximum point, and then to decreasing. Axis of symmetry, it's the equation of the vertical line that the parabola is symmetrical about. So like on this red one I did, the axis of symmetry would be like split it in half here. It'd be where it would be symmetrical about that. And then on the green graph, it'd be like right down the middle of it there. And then zero roots. They're just other words for x-intercepts. It's where the line crosses the x-axis. So the words zeros, roots, x-intercepts, those are all synonymous. They all mean the same thing. So just whenever you hear zero or you hear roots, it just means x-intercept. It's just another word we use when we're dealing with quadratics. And then you know what the y-intercept is. It's where it crosses the y-axis, where x is 0. So those are just little notes for you there. So let's look at these graphed quadratic functions. So they're already graphed for us. So now we just have to identify the features. So I'm going to do A here. So first it says vertex. So the vertex is that either minimum or maximum point. In this case, it's this maximum point up here. It's when the graph goes from increasing, and then after that, it'll start going back down, decreasing. And the coordinate of that is 4, 9. So that's the vertex. Now, the axis of symmetry goes through the vertex, and that's a very important concept. The axis of symmetry goes through the vertex. It kind of splits that parabola in half. So this dashed line I'm drawing is our axis of symmetry. And that line is that vertical line. And remember, we express vertical lines with x equals. So that's at x equals 4. So the axis of symmetry always goes through the vertex. So really, these numbers, and you'll start to see this, those numbers should always match up because the axis of symmetry goes through the vertex. The roots are just your x-intercepts, right? So we have it at, let me do that in a different color, at +1 and +7. I'm going to write them as a coordinate. You don't have to. You can write them as just 1 and 7, but I'm going to write them as a coordinate. So 1, 0 and 7, 0. So 1 and 7 are our roots. You could have just written 1 and 7. And then the y-intercept, that'd be here at 0, -7. All right. You try B. So kind of looking at this from an application, let me talk about number 2. So parabolas can help us model things in flight. So what it says here, the height of a baseball hit in the air is given by the graph's parabola below. Fill in the blank and then circle the feature the sentence is referring to. Okay. The initial height of the ball when it was hit by the bat. So at time 0, when it was initially hit by the bat, would be right here. That's our y-intercept. And it's at 5 feet. That's the initial height. It's when it's boom, hit by the bat. And then it flies up in the air, right? And then it'll come back down, obviously. But B says the maximum height of the ball was approximately, okay, so the maximum would be here, right? It's the highest flight of the ball. And it says approximately, so I think that's maybe 69, maybe. It's pretty close to 70. So I'm going to say 69 feet high. And that's referring to the vertex, right? That's the maximum there. C says after blank seconds, the ball was at its maximum height. That's referring to our axis of symmetry. Right? Because this time in seconds is down here on the x-axis. So the time in seconds when it reaches maximum height was 2. At 2 seconds, it reached its maximum height. And then D says after approximately how many seconds the ball hit the ground? Well, the ball looks like it hit the ground a little past 4, way over here, right? That's when it hits ground at height 0. And I'm going to estimate that at about 4.1 seconds. Okay. Number 3 says identify the features of the following tabular quadratic function. So now we have them in tables. So sometimes it might be helpful to kind of sketch it out if you're struggling, but I'm just going to kind of wing it here in terms of the table. So first ask for the vertex. Remember the vertex is either the minimum or the maximum. So if you look at these values, it looks like it's going down, right? Then down, then down. Oh, I'm sorry. No, it's not. It's going up. It's going 0, 5, 8, 9, right? It's going up. And then it hits 9, right? And then it starts to go down. And you don't have to write that, what I just wrote there. So it starts to go up. And then once it hits 9, it starts going down, the y values, right? So that means the vertex, our maximum point, had to be here. Think of it. It goes from 0, I mean, look at my hand, from 0 to 5 to 8 to 9, then back down to 8, then back down to 5, then back down to 0, and then it goes even farther down to -7. So that's the vertex is at 1, 9. And the axis of symmetry goes through that vertex at 1. Right? These will always match up because the axis of symmetry goes through the vertex. Now our zeros, which are our roots, are x-intercepts. Remember, our x-intercepts are when y equals 0, or in this case, f of x. Remember, f of x and y are, similar. So that would be at -2, 0, and 4, 0. So I just looked here. That's when f of x is 0 and at -2 and 4. Okay. And then our y-intercepts when x is 0, right? So that would be at 0, 8. So yeah, that's how you can kind of identify those features from a table. Now, of course, if you want to, you're more than welcome to sketch it out, get some grid paper and just kind of plot points and do it that way. So I'll let you do B and C. And speaking of kind of graphing it out, that's what we're going to do with number 4. So it says complete the tables for the following functions, then graph the points on the coordinate grid, and then we're going to find the key features. So I'm going to do B. It's a little bit harder than A. I'm going to do B out of these examples. Okay, so we're going to fill out the table. Now, there's not obviously a ton of room for work here, but in order to fill out this table, we're going to have to substitute all of these values into the equation for x to fill out the table. So let's just start with -6. Here we go. Okay. So I'm going to write out the work for -6, or at least most of it. So I'm going to do 2 -6 squared plus 12 times -6 plus 10. So -6 squared is 36. 12 times -6 is -72 plus 10. 2 times 36 is 72. So 72 minus 72 plus 10 equals 10. So my, oh my, I wrote really fast there. Sorry about that. But that's for -6. I'm going to keep that up there. I might have to erase here in a second because I'm going to run out of space. It might be easier if you do this on a separate sheet of paper too. Let's do -5 now. Okay. So that was for 6. Let's do, so maybe I'll label this as h of -6. So now I'm going to do h of -5. Okay. So 2 -5 squared plus 12 -5 plus 10. -5 to the second power is 25. 12 times -5 is -60. 2 times 25 is 50. I have 50 minus 60 plus 10. 50 minus 60 is -10 plus 10 is 0. So this is 0. Whew, okay. Let me do -4 now. I'll do it down here. I'll do it down here. H of -4. So 2 times -4 squared plus 12 times -4 plus 10. That's the function. Okay. -4 squared is 16. 12 times -4 is -48. 2 times 16 is 32. 32 minus 48 is -16. -16 plus 10 is -6. So this is -6. Yeah, so if this seems like a lot of work, it is, right? I'm filling out the table. It's a lot of work, but just plugging it into the function, filling out the table, and we're going to plot the points here in a second. I guess I can try to squeeze in -3 over here. I'll do that. H of -3. So I'm going to have 2 times -3 squared plus 12 times -3 plus 10. Sorry. It's a really bad looking 3. So that's going to be negative. I'm going to shorten this up. -3 squared is 9. 2 times 9 is 18. 12 times -3 is -36. 18 minus 36, -18 plus 10 is -8. All right. I'll do -2 now, I guess. All right. So h of -2 -2 squared is 4. 2 times 4 is 8. 12 times -2 is -24. 8 minus 24, what's that? -16. And -16 plus 10 is -6. So this is -6. And this is kind of interesting to me because if you start to look at the table, I think we've already found our vertex. It goes 10, 0, -6, -8. Now it's back up to -6. So if I'm predicting, I think the next one for -1 might be 0. I think it's gonna, it's gonna go down to -8. It's gonna come back up. I think the next one might be 0. But let's just triple check that. So let's plug in. What am I on? -1. So h of -1, 2 times -1 squared plus, 12 times -1 plus 10. -1 squared is just 1. 2 times 1 is 2. 12 times -1 is -12. 2 minus -12 is -10. Sorry, 2 minus 12 is -10. -10 plus 10 is 0. Aha, it is 0. So I'd be willing to bet if we plug in 0, we're going to get 10, right? Kind of see the pattern here? And plugging in 0 will be super easy. Where should I do this? I guess I'll do this down here. H of 0. Honestly, it seems kind of silly to even do this because you'll see in a second. Because 0 squared is just 0. 2 times 0 is just 0. 12 times 0 is 0. So it's just 0 plus 0 plus 10 is just 10. 10 So when you plug in 0, it's just going to be this, last number. But anyhow, okay. Woo. All right. So I evaluated them. I plugged them all in, filled out the table values. I'm going to erase all this work because it just looks really sloppy. Okay. And if you need that work, obviously rewind the video. All right. I just want to make sure the graph looks as clean as possible and it doesn't mess us all up. And I showed an incredible amount of work for every single evaluation, but you might be able to do it quicker than me. Okay, here we go. Let's plot the points. So negative 610 would be here. Negative 50 is here. negative 4, negative 6 is here. Negative 3, negative 8 is here. Negative 2, negative 6 is here. Negative 1, 0 is here. And 0, 10 is here. And look how nice that looks. It looks exactly like it should. A nice, beautiful parabola. Curves really pretty. Everything looks symmetrical. It's all good. All right, sorry, my thing froze. Okay. Looks like it froze again. Hopefully it does not mess up and freeze on me. Okay. Looks great, right? Great parabola. So let's identify these features. So the vertex is at negative 3, negative 8. And you could see it in the table or the graph, but the graph is probably more obvious. Axis of symmetry, we'll just show this in red. Goes through negative 3, so x equals negative 3. And of course, like I've said a million times, or not just a few times, those should match up, right? They go through each other. The x-intercepts, the roots, they're at negative 5 and negative 1. So I'm going to write them as a coordinate, though. I'll just write them as negative 5 and negative 1. I'm just going to write them like that. The y-intercept I'll write as a coordinate. It looks like it's at 10, so 0, 10. All right, so I'll let you do the rest of the tables. I know that table stuff is a lot of work, but just, plug and chug.